Obviously Micro-X is all about miniaturizing X-ray. Our technology we're branding as nano electronic X-ray (NEX) as a little catch cry to because this is the technology that underpins all the products that we have, and you can see there the illustration of the big difference it makes. That's in our first product, the mobile X-ray. So the financial highlights for the year: a big lift in revenue, obviously. Large part of that because of the major contracts, $14 million worth of contracts that we secured during the year. While mobile DR sales have been fairly flat, that caused us to relook at our cost base and realign that with the slower ramp up in our direct sales as we transition from a sales model where it was Carestream doing all the selling to one where we are establishing our own global network of distributors. USA and APAC, obviously, the key focus for most of our sales, but we're expecting that Europe and the Middle East will grow as we get European approval, and our distributors in the Middle East get some traction as well. And as David mentioned, our cash position gives us a runway into 2024, so we're very comfortable there. Operationally, all 4 business units very busy through the year. I'll talk individually about each of the business units in some detail, but the highlights here in mobile DR, the rover, the big thing, as David mentioned, is building this cadre of distribution partners through the US and Europe to get the sales traction that we need. The launch of the new high-powered version of the rover, something we've achieved, and getting that certified in Europe is a key priority for us. In Argus, the ID X-ray camera, the key thing there is building the preparation for sales. We've got 2 very, very capable, formerly EOD practitioners themselves, one in the US, one in Australia, and they've been preparing the market for the launch of the product. So we have a number of people very keen to take first demos, and of course the response during the year to the Australian Department of Defence tender for Land 154 has been an important part of this year's activity. In checkpoints, two big milestones there have been the acceptance of the designs that we prepared for both the CT baggage scanner and the checkpoint itself. A little bit more detail about that. So that says that our customer, the Department of Homeland Security, is very happy with the design progress of those products. And similarly, the brain CT scanner, our partnership with Johns Hopkins University, is predicting that our imaging architecture solution for the brain CT scanner will actually outperform conventional CT by about a factor of, we'll have 4 times better resolution than conventional CT in a unit that's going to weigh 50 kilograms and be cheap enough to put in the back of an ambulance. So that's pretty exciting. I want to talk a little bit just about the technology that underpins all of this, because we are at the end of it a technology company. 3 different tubes that are occupying our attention at the moment. The first generation on the left is the next tube, which went first in the Nano and then it's in Rover, is now being in production for the year, for many years, and its reliability is every bit as good as we've been predicting. The second one you'll see is a reverse polarity tube, which it works in a very high duty cycle, so we have a lot of heat to get rid of, and for that reason we have to turn upside down. That's created a few little challenges for us, but it's still performing. The design is performing very well, and you'll see that the progression in the size is getting smaller, even though that's 160 kilovolts. And then the last little tube on the left is our concept for the tube that will power the brain CT, and that's a task that we'll be getting down to during this coming year. So that will be in our CT scanner. Now, there's no point in miniaturizing an X-ray tube if the electronics you need to power it, the high voltage, is giant, and because in the end you need to approach this as a holistic product. So we identified, while there's obvious cost and supply chain benefits about bringing this technology in-house, but a really important reason for bringing it in-house is we need to be as inventive in our high-voltage electronics as we have been in our X-ray tube. And I have to say the guys have done an amazing job. The generator there on the right is our version of generator, which is powering the rover. It's a little bit smaller and about the same weight as the one we have been buying from Canada, but it's 4 times the energy. So that's outstanding to squeeze that performance into that package. So which means that the rover that has 4 times the capability of the first generation has the same weight, size, look, feel as the original version. So that's important. On the left, you'll see the generator that's powering Argus, a huge technology triumph to get that so small. So, but that integration of the high voltage with electronics with the tube is a key part of us being able to make outstanding product designs going forward.
Does it use mains electricity in high voltage?
No, it all runs off battery. All runs off battery. All battery operated. The other common thread to our technology, and this is the third leg of our technology stool, is the imaging software. The images that our 4 different products gather can be processed with there's a lot of commonality to how we do the imaging reconstruction and indeed the imaging processing to gather as much information as you can from the image. And the team that we're building in Seattle, in particular on the checkpoints business, will be the core of our software development going forward. But the techniques have a lot of commonality. So again, the same theme is the same investment in technology finds application in all the different products. The strategic collaboration with Varex, recently breaking news, is actually really important for the company. The validation in global markets of this technology, because Varex is the recognized world leader in X-ray technology. There's hardly an X-ray company in the world that doesn't buy some of their technology from Varex in Salt Lake City. Both in X-ray tubes and detectors and high voltage components. So for them to want to make this alliance with Micro-X sends a very strong signal to global markets about the maturity and strength and leadership of our technology in this world market. So it's really got a lot of people internationally taking notice. As part of the deal, they have a license to make multi-beam X-ray tubes. Now that is not a conflict with our roadmap of products, all of which use single emitter X-ray tubes. So this license gives us an opportunity to monetize an area of the technology that we have developed and owned, but had no plans to use. So it's quite a smart deal for us for that reason. And backing that, the company, because they want to see a long-term collaboration, wants to make an investment of 9.9% of the company. They've done half of that already. And with Andrew Hartman joining the board, I think the alliance between our companies going forward will be very strong. So going over to the business units, and please, that message is very strong. It's one company, 4 business units. Talk to each of them in turn here. Obviously, Mobile DR, our first technology proving product, is still extraordinarily competitive. We get nothing but rave reviews from users around the world. The versatility, it started in hospitals, it's moving to military hospitals. Here in Adelaide, we have 2 door-to-door X-ray services. The unit is so mobile and so easy to maneuver. They're doing X-rays of patients in their front living room at home, as well as obviously being able to wheel it into aged care facilities to X-ray patients who've got serious mobility issues. And of course the veterinary market as well. But we've got over 250 units in service in 35 countries around the world, and it's demonstrating the reliability of this technology. We offer a tubes for life guarantee because this electronic emitter is so reliable. We're guaranteeing a 10-year life for the tube, which is the intended life of the equipment. That's unheard of. And it really underlines and supports the concept in we talked about the old-fashioned X-ray tubes being the incandescent light bulb moving to the LED and the great increase in efficiency and life. And it's an exact parallel in our X-ray world. David touched on the feedback we're getting from the Ukraine. We have 12 units in the Ukraine. Bought by a US-based charity, which was actually funded to do so by the US government. We're in contact with the doctors that are using some of these, one particular in Kherson, and they're desperate for us to get some more units, and we're hopeful that might be possible one way or another. But the use they're making of it, as David said, is outstanding. There was one unit that we remoted into. We saw 6,500 X-rays taken in 43 days, which gives you a level of indication of the kind of human casualty. And it might not be very obvious to see, but if you look carefully in that X-ray, which is a screenshot that this doctor sent us, and literally just took a screenshot with his mobile phone and sent it to us. But you can see this patient here has a bullet wound that's a high-velocity bullet that's shattered his humerus. You can see you can actually see the track of the bullet in the soft tissue in the X-ray, the entry wound on the inside and the exit wound on the outside. But that's the kind of trauma use that they're doing, and if they need 400 of those X-rays a day, you get some idea of the intensity of the conflict. And we're very proud that our technology and the quality and design and build is standing up to that when required. Also saving lives, of course, the Argus. The concept here, of course, you might be familiar, is to be able to remove the EOD technician from anywhere near the explosive device. The concept of the camera, i.e. self-contained with the X-ray source and detector in the one unit, means that the X-ray can be taken. It's a self-contained unit that can be carried downrange by the robot.
Disrupt the device remotely.
Our X-ray doesn't do that. The standard way they disrupt bombs is a high-speed water cannon, which is directed at the energetic components within the bomb. So what they need from us is a high-resolution image to show what's inside, to show how they can aim the water disruptor. So huge effort from the mechanical design team here in squeezing that technology. It's our first X-ray product operating at 160,000 volts, which has its challenges. and squeezing that into such a small package at only 17 kilograms required some enormous invention. But we'll be very excited to start this in the new year. As David mentioned, we've had a few challenges as we transitioned this into manufacturing. Our yield was not high enough, which indicated that the technology wasn't yet as robust as we needed for a full product launch. One of the issues that we've had is the epoxy encapsulation of the high voltage. And it turns out that there's a lot of science that we needed to learn about the chemistry and physics of using epoxy as a high voltage insulator. But we're through those and hoping we're through those issues in the coming few weeks. But the product itself is very well designed, already operating, and as you've seen, producing exactly the kind of high resolution images that we were banking on. In checkpoints, the market opportunity is huge. In 24 billion, we estimate. And what we're doing here is enabling a dream of the TSA, the Transportation Safety Administration in the US, to change from the traditional checkpoint to one that's self-service. As you're probably aware, everything in airports is now self-service, from check-in to getting your boarding card to getting rid of your hold luggage to access to the boarding gate. It's all self-service. The only thing that still needs to be manned is the checkpoint, and that's what they want to attack. The unusual thing is that with this system of self-service, you can actually get a higher level of security as well as a better passenger experience. Normally, those are mutually exclusive, and that's why everyone's getting very excited. The little illustration on the right shows 7 of our self-service portals. We choose 7 because that's the same footprint as one normal conveyor belt X-ray system. And airports, of course, think in how many square meters do I need. So that's the concept of what we're doing. We have 2 contracts from the Department of Homeland Security, which is the owning body, if you like, of the TSA within the US government. The first is for the CT baggage scanner itself, and as I mentioned earlier, we've passed the first design review of that, so we're in detailed design, leading to the supply of a prototype of that in early part of next year. The TSA are so pleased with how we're doing, they've actually amended the contract recently. You may have seen our announcement for us to make a second prototype, because they want to accelerate the program by doubling up the testing in parallel to assess the capability there. The second contract is for the design of the self-screening portal itself. That contract is ongoing, will complete in about a year. The concept there is integrating the document recognition, the scanning, and the CT image of the baggage in, again, self-service, so that you can do that in itself. So, and again, that design that we've produced has been accepted at the first design review by the DHS. So we're into the next stage of that contract. I'll show you a little video here. The genesis of this, it was put together quite quickly for a conference last week in Las Vegas. The TSA organize every year an international conference where they invite basically airports, or the security chiefs of airports around the world, to come and listen to what's news from the TSA. So it's TSA talking about their direction and their achievements and their sense of the problems to airports around the world. Obviously, TSA somewhat the thought leaders in airport security. So there were airports from all over the world there, including from Sydney and Melbourne Airport, and of course TSA, with this vision of the new world, wanted us to present how does this going to look to everyone at this conference. So we put this video together very, very quickly, which kind of shows you, brings to life what the self-service portal is going to look like. So our passenger here, this is actually one of our engineers in the Seattle office, and some of our colleagues. So access into the portal, that's the baggage scanner. So the when one person leaves, then it's free for the next passenger to come in. So they get the documents scanned, which allow them entry. The cabin luggage, you don't need to take anything out of the cabin bag because it's a CT image. So your personal effects and that go in. All the time the passenger is moving, they're being scanned by the millimeter wave. So that, and then while we produce a three-dimensional image like this that can be viewed, the first assessment is done in an automated way by our software. So only if the software detects something will a human need to look at a three-dimensional image to resolve the potential threat. Once it's clear, then you pick your bags up and you walk out of the portal. So that's a first little glimpse of what the airport of the future is going to look like, thanks to MicroX technology. So, great job there from the team in Seattle. Lastly, the brain CT scanner. Similarly, great progress on schedule. Commercial product in 3 years. A year and a bit from now, we'll be doing our first imaging of cadavers, and from there into patient trials. Live patient trials requires a bit more paperwork, but our partners, Johns Hopkins, as I mentioned before, are predicting that our image quality is going to beat that of conventional CT. Just to remind you that the goal here is we've got to be able to image a bleed, because this device works by confirming that there is no bleed. If there is no bleed in the brain, then it's safe to administer to thrombolize the patient, basically give the clot-busting drug. Because if there is a bleed and you give a clot-busting drug, then the patient dies. So hence, they will not start that treatment without a CT image. And our image is likely to become the new standard of care with that level of resolution, because we'll outperform a standard helical CT. So we're pretty excited about that, as indeed are people around the world. So the interest we're getting from people around the world, literally tracking us down and saying, when can I buy one? And the case of the Norwegians, they want to help in the regulatory approval and early imaging tests, is really quite exciting. On the ESG front, something that we're monitoring that's very important to the company. We have a reconciliation action plan in development. Our diversity in employment is something that we're working hard on. Very, very pleased with our safety record. Our production environment almost completely staffed by ex-GMH Holden employees who had a great attitude to safety, which they've brought with us, and so our injury record's really very good. Working on electricity usage, we have been using a lot of electricity in our tube production bake out, but we found ways to reduce that significantly as a contribution to the ESG goals. Working very, very, very hard with our local community here, promoting STEM, because this company will have an appetite for clever young engineers and technical people in manufacturing for a long time. So promoting interest in STEM with school age children is our investment in the future. We have been working on a big improvement in our IT security, even before the events of recent months. And something that we take for granted, we've been qualified to ISO 13485 for 6 years now, and get audited every single year. So every single one of our processes in management and the operation of the company is audited every year. So as a testament to good governance, that quality assurance rating is very important. So I'd look up for next year, getting Argus into its first sales, which will happen in the first half of 23. We got a number of potential first customers in mind, but obviously the Department of Defence's Land 154 tender decision, which hopefully will come sometime in the next month or two, will be a big influence on that. Our CT baggage scanner, first prototypes delivered to the TSA during the year, completing the design of the self-screening checkpoint, and that's really been designed from the ergonomic point of view, that passenger interaction that video was all about. Growth in the mobile DR sales with pipeline and increasing the conversion. Launch in Middle East, important. Obviously, brain CT development continues to get something ready for first imaging. And obviously our support for the technology transfer that we've signed with Varex. So thank you for that.